Hi guys. Today we're starting our last new unit of chapter 2. We will spend today and tomorrow learning about graphing inequalities. You will need graph paper for today. What we've been doing so far this chapter has been working with linear equations. An equation is something with an equal sign. When you see a problem with an equal sign in it, you're going to graph me a nice straight line. Today, we will not be graphing an equation. Instead, we'll be graphing an inequality. And an inequality is something like a less than or a greater than or equal to. Because we're graphing an inequality, we will no longer be graphing just a straight line. We will also be coloring in about half of the graph. This is called shading. So when you see something with an equal sign, you're just going to draw a nice straight line. But if you see something with a less than or a greater than, you're going to need to go a little bit further and also shade. Let's do an example. When you're starting these problems, you'll start it by drawing a nice straight line. You can leave the problem in the format that it's in. This is called standard form. And remember, when we're graphing standard form, we can use the cover-up method to find our x and y intercepts. Or if you prefer slope-intercept form, you can change this to slope-intercept form and graph it that way. Either way, you should be putting a dot at the 1 on the y-axis and at the 1 on the x-axis and getting this nice straight line. Now, I'd like to point out that this nice straight line, it's not a solid line like what we would normally graph if it was an equal sign. It's a dotted line. The way that we tell if we should be drawing a dotted line instead of a solid line is by looking at our inequality. If the inequality is just a less than or just a greater than, then you're going to graph a dotted line. If it has the or equal to underneath it, then you can make the line solid. Since this one was a greater than, I had to draw a dotted line. Now again, we do not stop with a line when we're graphing an inequality. We need to go one step further and figure out which part of the graph we should shade. We're going to use my red dotted line as the boundaries of where the shading would happen. So we're either going to start at the red line and shade up, or we're going to start at the red line and shade down. And the way that you can tell which half of the graph gets shaded is by plugging in a test point to your original inequality. When choosing a test point, it needs to be a dot that is somewhere not on the line that you drew. We want to test somewhere in the white space. Whenever possible, it's best to choose 0, 0 because plugging in the number 0 to an equation is just so much easier than plugging in another number. So I'm going to use a test point 0, 0. That's 0 for my x and 0 for my y. And I'm going to plug it into the original inequality. And I'm looking to see, is this true or false? Does it work or does it not work? Okay, so when I plug in 0, 0, that's 0 plus 0, which is just 0. And I get the inequality 0 is greater than 1. Now that is not true. That does not work. 0 is not bigger than 1. That is false. That means that this green dot right here is not an answer to this question, which means I do not want to color where this green dot is. And so instead, I'm going to color on the other side of the inequality. I'm going to color above the line. And again, you're shading all the way up till you hit the line. And once you get to the line, then you stop shading. The line with the shading is your final answer. Let's go over those steps one more time. When graphing an inequality, before you draw your line, you should decide if you're going to draw a dotted line or a solid line. Dotted lines do not have an or equal to, Solid lines do. A solid line is just the type of line we normally draw. Then you should graph your line. You can keep the equation as is, or if you would like to change it to slope-intercept form, you are allowed to do that. After graphing the line, pick a test point. The test point can be any point on the graph as long as it's not on the line that you drew. When possible, it's best to choose 0, 0 just because it makes the math a little bit easier. You're going to plug the 0, 0 back into the original inequality. If you had to change the inequality to graph it, don't plug it into the new one, plug it into the original. Finally, if you decide that your test point is true, you're going to put your pencil on top of the test point and you're going to shade on that side of the line. If you decide that your test point is false, you're going to hop across the line to the other side of the graph where the test point does not exist, and you will shade that side of the graph. Once you're done shading, you're done graphing. Let's try one more. Make sure we all understand what to do. In this problem, first, I'm going to make sure I know this one will have a solid line since it has the or equal to. Now, in this particular example, I cannot graph it in standard form because the x and y intercepts are both the origin, and I have to have at least 2 dots to draw a line. And since I'm only going to get 1 dot on the origin, that's not going to work for me. So in this problem, I must change it to slope-intercept form. This is what it looks like in slope-intercept form. Again, my y-intercept is on the origin, and my slope is the invisible number 1 in front of the x. So we're going to rise 1 and run 1. And we draw a nice solid line. Now in this problem, my line does go through the origin, so I will not be able to use the origin as a test point. In fact, I'll already tell you that the origin works. The origin it's an answer to this problem because the line goes through it. So we got to pick a different dot. Yeah, it doesn't matter where you pick the dot. You can pick it anywhere in the white space as long as it's not on the red line that you drew. So we can pick a dot above, below. It can be on an axis, off an axis. It does not matter. And close your eyes and point and pick that spot. Okay. So I'm going to pick this green dot right here, which definitely is not on my red line. And the ordered pair for that dot is 2, 0, 2, 0. I like to draw where the dot is so that when I go to shade, I will remember, is my dot below or above? When you're plugging these numbers into the original problem, again, the original, not the new one, make sure that you're plugging in the numbers to the right letters. So the first number is your x coordinate. It's going to go right here. And then the second number is your y coordinate. It's going to go right here. And 2 minus 0 is 2. And on this problem, we have discovered that 2 is indeed greater than or equal to 0. That is a true statement. So in this example, since my test point was true, I'm going to put my pencil on the test point, and I'm going to shade the side of the graph where the test point is. So again, when it's true, you want your shading to cover up the test point. When it's false, you would shade on the other side. Now, I said let's do one more, but I actually have 2 more examples to show you really quickly. It's those special cases, so let's just breeze through this as quick as possible. So in this special case, we only have one letter. It's the letter X. So we're going to go on the X-axis to the number 3. And when it's only the letter X, we draw a nice vertical line. And in this scenario, it's going to be a solid vertical line since it has the or equal to. Now, if there's only one variable, you don't have to use a test point. If you don't want to, you can use common sense to figure out which side to shade. In this problem, it says I want all the numbers that are less than 3. The numbers that are less than 3 are this way. So we're going to shade that half of the graph. So again, when there's only one letter, you are allowed to just use common sense to figure out what half to shade. Let's do just the letter Y, and then we'll be done with this video. In this problem, I have y is greater than -4. So I'm going to go down to the -4. I'm going to draw a nice horizontal line through the -4 on the y-axis. This time it's a dotted line because there's no or equal to. This problem says I want all the numbers greater than -4. So if here's -4, greater would be above. So I'm going to graph above. This concludes our first video.